Of it, and I have a line through it, meaning I am not going to teach you on that, test you on it, because that's a little tricky, especially like problem 24 that we had a couple days ago on well, 24 is one part, here's some more of them. And so that application, part of it is extremely easy, except if you have it running from A and the B is not linear. If it's square and cubed, it makes it a lot more difficult. And I'm not really interested in that, okay? And so you'll have a question or two on Riemann sums. You'll have the fundamental theorem of the calculus, and then some applications.
And that's it?
Okay? Now, that average stuff that we're doing today and yesterday, that's not going to be on it. Not that average stuff. But on the average stuff is what I'm going to start with right now. Here we go. You notice, by the way, pass your stuff in. This is, I think, the problem that's in your book. I would like to just spend a couple minutes with it so you have an idea what this is doing. The reason I do this is because the author is getting us ready to think of other things he's going to do the same thing with integrals, at least related to this. I'd like to find this average, and that's going to be 1 over b minus a, and then we do the integral stuff, okay? But 1 over 1 minus 0 is 1. Are you with me? So, we're going to find, well, we'll just do it this way, like this dx, and 0 to 1. And so this is going to give me 1, and the antiderivative of that is x to the n plus 1 all over n plus 1, like this, evaluated from 0 to 1. Now, this turns out to be nothing more than 1 over n plus 1. Okay, we looked at that yesterday. But I didn't spend the time, because I had a student ask me about it, and we went over a little bit. I'd like to show you what happens when n equals 1. This is what you have. Oh, hi. There it is. That's a function that goes this way, and we're going to stop at 1. Well, what's the average of all these? It's just going to be a half, isn't it? Yeah. And so, in this case, n equals 1, so it's 1 over 2. Okay, now let's look at the next one. And that's kind of cool. It goes like this. And this is f at x equals x squared. Okay? And now, what is the average? We're stopping over here from 0 to 1. What's the average height? It's going to be over here. It's going to be 1/3. You with me? Now we'll do one more, and you say, oh, now I get it. It's really easy. Now we're going to go like this, and it's going to be f at x equals x cubed. Now, over here, what is the average of all these Riemann sums? 1/4. Okay? Now, questions on that? Did anybody have a question on that?
Well, how do you figure that out besides just seeing it?
By up here.
What would you plug in there for the x?
Oh, okay. Notice here, n is 1. Here, n is 2. And here, n is 3.
Good.
Okay?
That makes sense.
Got it? Okay. Now, the next thing. I did hear a question on that St. Louis problem, and we'll, if we have time today, otherwise we'll try to do it on Thursday at the beginning. Okay. I'm going to find the antiderivative of some things here. We'll start out with this one, which is kind of nice. We'll make that 7x dx. What is the antiderivative of that? Okay. It's going to be e to the 7x over 7. Right? Now, if you wanted to use U substitution here, you do this. U equals 7x. So du equals 7 dx. Now, I don't have a 7 here. That doesn't count. That's up in the exponent. So I'm going to put a 7 here, and I'll put a 1/7 in the front. Any questions about reason why? Okay? Now, so I got that. Now, when I do this, this is 1/7, and then look what happens here. This business here is du, because I set it right over here. See, that's du. And then this is just e to the u. And now this is always itself, which is a wonderful gift of God. E to the u plus a constant. And then I sub this back in here, and I got it. Okay? Now, yes?
Why do you make du 7dx?
Right here?
Derivative
Yeah.
of u.
I took the derivative of both sides here.
Right.
And that becomes a du, and this is 7dx.
Okay.
Got it?
Yeah.
Okay. Now, now we're going to get into a little more trouble. And what I'm doing is the indefinites. We really want to get to the definites. We'll get there in just a few minutes. Okay? But the indefinites, we've got a couple just to do a little more practicing on. How about this one? I'm going to change this one in a moment. No, I didn't want that. I didn't want that at all. I don't want that either. I'll just do it this way. Sine x dx. Okay, now, what is the antiderivative of that thing with U substitution? What am I going to make u equal to?
Cosine.
Cosine, not sine. I'm going to make it equal to the cosine, this one over here. And you're going to see what happens in a moment. Now I have this. What's the derivative of this, Jeff?
Sine. Maybe sine? Yeah.
Okay. Any questions about that? Okay, now,
What do you do?
this is going to turn into a u. So there's a u. And it's u cubed. Okay? Now, here I have a positive, and this is a negative, so I'm going to put a couple negatives out here. With me? Now, this part and this part here make this du, because du is equal to that. See that?
Yeah.
Part? Okay, now this, oh, here's a minus over here. Now this is pretty easy. This gives me, no, I don't want that. This gives me a minus u to the plus a constant. And see, when we get rid of the definites, then we don't have to worry about that constant anymore. So my answer is going to be minus, and then we got to put it back here, a minus cosine to the 4th over x all over 4 plus a constant. Okay? Yes?
Why did you put 2 negatives in?
Because I needed one over here to get this du. Because see, my du has this whole quantity, and I'm going to, for this, I'm going to substitute a du.
Okay, and then why did you put one on the outside?
Well, I can't change something from a positive to a negative. 2 negatives still keep it a positive. Okay? So I didn't change its value. A negative is a positive, so I just used 2 of them. One was used for this, and the other one was used for something else. Got it? Okay, thank you. Okay, now, the next one I'm going to do is it's found in all calc books, and we run into this kind of thing a number of times, and it's going to be the x over the square root of x plus 1 dx. This does take us a little bit of work to get this thing done. Part of it is the calculus part, more important than the algebra part. Okay, so what's u going to be equal to?
X plus 1.
Okay, now we could square both sides if we liked, but I'm not going to do that. I'm going to leave it this way. I'm also going to do something else, and it's going to be handy in a minute. I know that u minus 1 equals x. I'm going to need that pretty soon. Okay, I just solved it for the other. Now, this gives me du equals dx. Any questions about that?
Why is it du minus?
Okay, now, what I have here, this just turns into du, got that done. Now this here, I went u, so this is going to be a u minus 1. See it?
Yeah.
I needed it over here, and this turns nothing more than the square root of u. Are you with me at this point? Now, see, they have this one in all the books, they said, I've ever taught, because of all the things that kind of happen. I'll put this together this way now, and that's going to be the square root of u minus 1 over the square root of u. Any questions about that? how this became this?
Yeah.
Okay. This here is, this u is actually square root of u, square root of u. That's just a u. And that's a minus 1. And this has over the square root of u and over the square root of u, like this. That means common denominator. Got it? That cancels, and now I've got this over here. You didn't follow it yet? Okay.
Why do you have to do that? Like,
Because I can't operate here, I can't operate here. I don't know how to do this. And the other thing is, we learn common denominators, but sometimes it's nice if we don't use common denominators. Just spread them apart, okay? Instead of combining them like that. Okay, now, this becomes like this. U to the 1/2 and du, I'm just gonna do it this way. No, I don't want to do it that way. You don't have to. Minus u to the negative 1/2 du, like that. With me? Okay, now I'm going to start writing a little smaller, because I've got a little ways to go here. Now I'll just go over this side. Okay, this becomes u to the 3/2, 3, 2 like this, with me? And this becomes minus u to the 1/2, 1 down here and a 2 up here. Question on that? Plus a constant. Questions? Now I'm going to substitute back, and here I want you to follow through, because today some of the stuff can be done with CAS systems, and then you have to know how to factor, some special stuff with factoring. So I'll make this equal to 2, and I'll put this is equal to up here, which is this. That gives me x plus 1 to the 3/2 over 3 minus 2, and then this is going to be times x plus 1 to the 1/2 all over 1. Okay? So, plus a constant. What I'm going to do now is factor this. Now this is where the algebra comes in. This is the answer in many ways, but it won't appear that way. Then we'll take this out of here and here. So I'm going to take, and I'll take this 2 out. So this gives me 2x plus 1 to the 1/2. And then what's left? I've taken this and this out of here, and what's left here then is just going to be x plus 1 over 3. This 3 is still there. There's just one of these because I took a half of them out. Okay? Square root of them out. And this is going to be minus 2. Okay? Question about that? Now that's plus a constant. And this can be simplified. That gives me x plus 1 minus 6 all over 3. Okay? Now this 3 could come out over here, and that becomes 2 over 3 times x plus 1 to the 1/2, and then this becomes x minus 5 plus a constant.
Wow.
Question on that?
All right. That's the answer.
Yeah, that's the answer. Okay? Now, this one isn't a whole lot poorer, but this is the one you could probably get coming out of a CAS system, and if you stopped here, you say, are those two equivalent? Okay? So, just wanted to take you through that thing, and now we're going to change from that to definite intervals. And that you're going to probably like better. So, we'll start with this. How do I want to go? 0 to 4, definite interval, and we're going to make this 2x all over x squared plus 1 dx. I think that's what I want. Yeah, I'll just start there. That's good. Okay, now, what am I going to make u equal to? U substitution.
x squared plus 1.
X squared plus 1. Now, do your little check. This is du, and it's equal to 2x dx, right?
Yeah.
And notice what we have here.
Oh,
See that?
no.
Okay?
Nice.
That cool? Okay, now, the next thing we're going to do is we're going to change these. These are on the x-axis, and I'd like it on the u, so I don't have to change it backwards. I don't have to redo it. That's what I'm doing this for. And so your author does it a little differently than I do it, but I kind of like this method. X is going to go from 0 to 4. Now, up here, when x is 0, what's u going to be equal to? Okay, and when x is 4, it's going to be equal to 17. So my new problem is this. We're going to go from 1 to 17, and this is du, and the bottom is going to be 1 over u. Are you with me? Yes.
Can you go over what you just did?
Yeah, okay, because I'm just about finished. This is so cool. This here?
Yeah.
Okay, these are evaluated on the x, and I'd like to make them a u. Change it to a u instead. So, and this is what I said was true. Okay, that's true. So if x is 0, then u is 1, and when x is 4, it's equal to 17. Okay, what's the antiderivative of 1 over u?
ln u.
Yeah, ln. So this is going to equal ln of u, but it has to be absolute valued, and we're going to evaluate it from 1 to 17. So this is going to be ln of 17 minus ln of 1. And this gives me ln of 17 over 1 like this, which is ln of 17, and I say goodbye. I'm finished with the problem. I'm off to the next one.
Well, that was cool.
Isn't that cool?
No. Well, I just make it 1 over u.
Oh, why?
Yeah.
Up here?
Yeah.
Because I said u is equal to this, so I just put a u down here.
Why did you make a copy of it?
Because I had already removed this, and now I'll put a u there.
Okay.
So now I could have written a u here. I don't like it written up there. I usually like it at the back here.
Alright.
Otherwise I get confused. Okay? Any questions on that? Okay, now, boy, are we moving. That assignment up there, 5.5, you do have some time because of block scheduling tomorrow. Although I might not spend a lot of time on it, and maybe not even, let's just put it this way. I won't ask it to be due on Thursday. It'll be, but hey, if you want to, push it off and get a problem, but otherwise we'll figure that's due Friday. I will give you a couple more problems besides that for Friday, depending how Thursday goes. The other thing is, if any of you need any help with the review, I plan to be here tomorrow morning. Okay? I plan to be here tomorrow morning. And what time? Oh, 8 o'clock is early enough, right?
Certainly.
Okay. And okay. Now let's do this one. We do a fair number of sines, tangents, LNs, and things like that. You guys are pretty special in where we really push that because this is transcendental calculus, and it's not a business type of calculus, so those are all here. And this is what I have in this particular problem. We're going to try to figure out, cosine x dx. Okay? Now, how are we going to deal with this one? We're going to do U substitution, so U is going to equal what?
Sine of x.
I don't think so.
Why not?
Oh yeah, excuse me. You're right. Yep. Sine of x. And then du equals cosine x dx. Okay? So now, and the other part is this. Here's x and here is u. When x is 0, u is
1, 0, 2.
okay? And when it's equal to pi halves, it's equal to what? 1. Okay? Any questions about that? Again, you're seeing the need to know some of these trig kinds of things.
So where did the x turn into the u at exactly? Are you saying that the antiderivative there, the cosine, when you plug it in for 0, it becomes that? Or what are you saying?
These numbers over here now. So
yeah, I got that. But why do you put them in? What are you doing with the u? Are you plugging those into the antiderivative?
Yeah, you see this is a du. See, now I'm evaluating a u. I'm there. And but I better also do this one, and that's going to be nothing more than u to the 4th. Cool?
Yeah.
Hey, by the way, did you get blood today?
Yeah, I did.
Thank you. Who else did? Thank
Andrew
you.
did.
Good. I did it about a week ago.
No.
Brianna did.
Okay. You see how easy this problem is from here on out? That gives me u to the what?
5.
And we're going to evaluate it from 0 to 1. So my answer is going to be equal to?
Cool.
Okay? Okay. I have one more, I think here, that I was going to look at. And just a second. I need to get something, right?
Hey everybody, it's in class. Hey Josh, hey Josh, hey Josh,
on this little sheet here, we have this relationship, and it's very handy. Tanner, I'll be with you in a minute. We have these situations. Cosine of 2 theta is equal to 2 cosine 2 theta minus 1. That's one of them. I'll give you another one in a minute. Now, what happens here, I could make this cosine 2 theta plus 1 divided by 2 equals the cosine squared of theta. Okay? Now, I told you back there that this is going to be handy sometime. Okay? And now it has here. There's another one that happens this way. We can just change that around, and it becomes cosine of 2 cosine of 2 theta is equal to 1 minus 2 sine squared theta, like that. See that? Okay, now we'll do the same thing as here. And so I'll get here cosine of 2 theta minus 1 from here. Oopsie, just a second. I'll do it a bit different. I'm going to put this over here. This is going to be 1 minus cosine 2 theta like this equals, put this on the other side, divided by 2 gives me the sine squared of theta. See those two? Now, here's a problem that I have. Finding the value from negative pi halves to pi halves, like this, of the cosine squared theta d theta. Okay, now, you notice we're going from like this, and this is an odd or even function.
Even.
So this problem could be written, and you don't have to do it this way. It'd be 2 times, and then we'll start with 0 and land up with over here, like this, cosine, just a little cosmetics over here. Okay, now I'm going to go to this. That equals now 2 times, and we still have 0 to pi halves, and we have this one right here. See that? Oops, see, where am I? Right here. See that? That's here. So I'm going to make this cosine 2 theta over 2 plus 1/2. Do it this way, d theta. Are you with me? I like it that you're eating those. That's important. You just gave blood, didn't you?
Uh-huh.
That's good. Okay, now, what is the antiderivative of this? Can we find it? We have a 2 out here. And over here, we're going to evaluate this thing from 0 to pi halves. And what's the antiderivative of this?
Negative cos or negative sine 2 theta.
Divided by 2.
Pardon?
Is it divided by 2?
Divided by 2. Okay, hey, let's do something else here a minute before I go pay. It's a little different than I thought for just a second. I want to do something else here a minute. I'm going to cancel this 2 with these 2. Okay?
You can do that? Like, why?
I just did.
No, I know, that you're Mr. Kramer. You can do that.
Okay, I did that because I could have put this in the inside over here. See, I just take this and moved it here, and now it's inside and disappears.
So you can move that thing around though.
Absolutely. And now you're hearing Grant talk. As a group, you've had some trouble all the way along on this one, where we have a constant times a derivative, or a constant times a limit, or a constant times a derivative. All of those and an integral. They all work that way, and so it's nice to be, err on side of caution. Okay? Now I have this like this, pi over 2, and now this is all I have left. And plus a half, plus 1, d theta. Okay? Now, so this is going to turn into, the antiderivative of this is going to be, I think it's going to be the sine of 2 theta over 2. Okay? Now, if you're having trouble with that, let's go check it out. Let's take the derivative of this. If we have this thing like this over 2, what's the derivative of that? dx. Okay? This turns into the cosine of 2 theta over 2, and then we have to take the inside here, chain rule 2, now they cancel, and so we got it. Got it? Okay, plus what?
Plus 1.
No, we don't have
X.
to do C's anymore.
Okay.
These are definites. This here, what's the antiderivative of this?
X.
Nope.
1 over
Just a little slip.
What?
We're doing thetas instead of x's. That's all. No big deal. Okay, I think you understood. Now I'm going to evaluate that from 0 to pi halves. Okay, now, watch what happens here. What is 2 times pi halves?
Pi.
Pi. What's the sign of pi?
0.
What's 0 minus 2?
Negative.
0 over 2.
Zero.
Okay, so that's a nice big 0. And so then this is going to turn into plus pi halves, right? And now we'd evaluate this one. If I put a 0 here, I'm going to get a 0, and that's a 0, so here's my answer. Okay? Yeah. Now, but you notice, Trevor, the big thing is moving from here into these. There are a couple other little ones like that, but that's, I probably could have taken you to the book also. In the front cover of the book, you have those same things.
This won't be on the test.
Oh, no, not this test. Not this test.
Never.
Okay? No, it's not never. Okay. Now, Kinza said she would like to do that problem, because I'm finished for today. You wanted to take a look at the,
The St. Louis article.
okay, here we go, St. Louis Arch.
What happens to the Probably,
Okay, where do we integrate? From what to what?
From 0 to 600, 30.
No, I don't think so.
What are you talking about?
I'm going to go from, what do I need to put down here?
Yeah, from 0. Oh.
A to B.
A to B, what is A?
that one.
Well, you
Okay,
can just do it
and
times
this is going to be
two.
315.
Can't you just do it times 2?
Yeah, can't you do the?
Okay, is this, do I have something wrong? No. I have a, okay, is this an even function?
Yes.
It is an even function. It is an even function, so I could put a 0 here and put a 2 in front.
Yeah.
Which, since you're suggesting it, we'll do it. By the way, what is this?
300.
1 over
630.
630. Now, I believe you guys wanted me to put a 2 up here, right?
Yeah.
Now, I'm not going to cancel this yet, because I've got something else I think that's nice. Now I'm going to put a 0 here and 315. And I've got a 630 over here. Now, Grant, look what I'm going to do in a moment.
Mr. Kramer, why is it 2 over 630?
Because it's 2 times, so we want to do
because it's an even function.
Oh.
You don't have to do it that way though. Okay, now I'm gonna take this 600 and I'm gonna cancel with that. Okay? Now I think I am in really good shape. I've got a 2 here. And I'm gonna take the antiderivative of this. Oh, I have to have dx back here. What's the antiderivative of that?
X.
X, okay. And what's the antiderivative of this?
Nasty stuff.
That, the third all.
X to the third all over 3 times 315.
Yeah.
Okay, and now that's all from 0 to 315.
Yep.
Okay? Now,
But
There's a square there.
isn't 315 squared too, or not?
No, it's, you do.
yep. Okay, this is squared because of it up here. Okay? And we're gonna like that. Okay, now, as we're going along here, this is my 2, and this is gonna be 315 plus, now notice what happens here. This is gonna be 315 over 3.
Cool.
And that should be my answer.
It's pretty nasty.
Oh.
Yeah,
Cool, bug, yeah.
yes. Hey guys, you wanna listen, Shannon?
You have x to the third over 3 times 315. Where did that 3 come from?
This 3, where did this 3 come from? Antiderivative of this, we had here x squared over 315 squared, which I kind of messed up. Okay? That's where the 3 came from. Yes?
That's double the correct.
Yeah, it's double.
Pardon?
That's double the correct answer.
Is that double the correct answer?
That's what I did. I'm like, no, I'll just take
Yeah,
this 2
it's
out of here.
Let me put it up.
Okay.
The 1 over b minus a, which is 630. Well, Mr. Kramer, I have to do that.
Yes?
Well, why could you make that bottom one 0 and you didn't have to, no, to your left,
Because he's doing the Kramer.
right there, yeah, why did you make that one 0 but you didn't have to change it?
Because we're only going halfway, it's an even function.
Okay.
Okay? I'll take a peek at that.